Hello viewers, today I'm going to take you through mathematics on a topic captioned second theorem, and that is for those learners for the challenge in second theorem in mathematics. Now, we're going to look at this question which is saying in the diagram below, A, B, C, and D lie on the circumference of the circle, center O. BO is parallel to CD, angle BAD is equal to 62 degrees, and angle BCE is a straight line, as you can see here in the diagram. And they are saying, calculate A angle T. Now understand this, first you have to describe this here. So these are parallel lines, meaning that these are not linked together. And apart from that, for us to find angle T, we use the property that says the angle on the center is twice the angle on the circumference. So for us to find this, we're going to multiply this by 2. So, right solution there. So, for us to find T, we say T is equal to 2 times the angle on the circumference, which is 62. So say T is equal to 2 times 2 to give us 4, and 2 times 6 to give us 12. So angle T is equal to 124 degrees. Why do we say it's equal to 124? Is because we say the angle at the center is twice the angle of the circumference. So this becomes our answer on the first one. Okay, now we proceed to B, which is saying calculate angle BCD. So we're trying to find angle BCD. So for us to find this, we're going to apply the theorem which says the opposite angles of a cyclic quadrilateral are equal to 180 degrees. The opposite angles of a cyclic quadrilateral, which is this one here, are equal to 180 degrees. So if you've been given this, we're going to subtract that from 180 to find this angle. So in short, we're saying angle BAD and angle BCD are equal to 180 degrees. So now if you have done that, you can proceed. BAD is 62, so write 62, and that is B that we're finding. Okay, so 62 plus BCD is equal to 180, and thereafter you can start right here. So you say BCD as an angle, as an angles. So BCD is equal to 180 minus 62 degrees. And then after we say BCD is equal to 180 minus 62. So you can start from here. Say 0 minus that, which is count. You can add 1 to that. And 10, this becomes 10, this becomes 7. So 10 minus 2 to give us 8. And this is 7. So 7 minus 6 to give us 1. And the 1 comes just the way it is here. So angle BCD is equal to 118 degrees. That is the answer. We now proceed to see what we're saying. Find angle OBC. So for us to find angle OBC, we're supposed to apply the property which says angles that are associated with the parallel lines are equal. In short, this here, this angle that we have is equal to that angle. But how do you find it? We can find it by subtracting 62 from 118. So we can say angle, that is C, angle OBC plus 62 is equal to 118. And thereafter we say OBC, you can start here, OBC is equal to 118 minus 62, this becomes negative there. So you say OBC is equal to this minus that to give us, that is, you just pause for a while there, pause for a while. Okay, so I'm going to redo question C, which is saying find an OBC. So for us to find an OBC, which is the OBC, we're going to relate this to this and also the 180 that we had found there. So OBC is equal to, you can say OBC plus the 118 that we had found here I say that this angle and this angle are the same. We need to find the same answer here. Why? It's because we're referring to angles associated with the prior lines. So we can say OBC is equal to 180 minus 118. So say OBC is equal to 180 minus 180 to give us 62. So I say that this angle must be equal to that angle. Why? Because these are angles associated with the prior lines. So that is the answer for question C. Okay, we now proceed. That's what you're saying. Find or calculate angle DCE. We're trying to find DCE. So for us to find this, we're going to apply the law or the property which says the opposite exterior angle of a cyclic quadrilateral are equal to the interior angle of the opposite interior angle of a cyclic quadrilateral. That means that this angle is equal to that angle. All put together. And that angle is equal to this angle. All put together. So we say that is D. We say DC. Stand here. DCE is equal to 62. And the property that you can say there, you say it's the opposite exterior angle of a cyclic quadrilateral. Opposite exterior angle. Exterior angle of a cyclic quadrilateral. So that's what you can put here. Just put it here. So that is the answer. So angle DCE is equal to 62 degrees. And there you're done. See you next time.